So welcome everyone to the masterclass today, and today we'll talk about the foundations of data science and business analytics. About myself, my name is Seth Lean. I am a data scientist working with Pacific Blue Cross here in Vancouver, Canada, and I do have a PhD in machine learning and artificial intelligence. I have including my academic experience, I have 9 years of experience in total. In the field, couple of years I've been with Great Learning, doing and mentoring different cohorts. And I work in the fraud department with Pacific Blue Cross as well, where we are building state-of-the-art machine learning tool to combat healthcare fraud. And in the past few years, we have been able to recover the highest money the company has ever done from fraud recoveries. So we're doing very well, and we are combating fraud almost every day. It's basically using the historical data and looking at the patterns in the historical data and extracting information out of that data to make a wise decision. And we are human beings are doing this every day at all times, because when we are growing up, we are creating data in our daily life. When we start walking, we are creating data how to walk. When we start eating, we are creating data how to eat. And then based on that historical data, we are training our brain to make a wise decision. What to eat, what not to eat, how to walk, how not to walk. So the analytics is exactly the same thing as what the human brain does. It's processing information and then using that information to make a wise decision. Okay, so and that's how you can summarize analytics. Fraud detection using machine learning, and as you know, machine learning or data science or data analytics is a buzzword that you must have heard in the past few years. They are applicable in every segment of life, and fraud detection is one of them. And fraud could happen everywhere. It's not just the financial world that deals with it. It could happen in healthcare. It could happen with identity theft. It could happen in any segment of life. Okay, and machine learning is used extensively, at least nowadays, in detection of fraud. So when you swipe your credit card and suddenly it gets declined, now there is not a human being sitting at the bank and purposely declining your transaction. When you swipe your credit card in an unknown location or a transaction that is not similar to what you have done in the past, there is a dedicated algorithm that is actually taking a look at it, and it see that it's not similar to what you have done previously. It's not a normal user behavior. What we'll do, we'll stop that transaction, and that's when your transaction gets declined. Well, there are other reasons for it to get declined. If you're over the limit, that's another reason for it to get declined. But let's say you are well within your limit of the credit card, you have money in the bank, but it gets declined for some reason, and that's usually because it's not a normal user behavior. Okay, so we are getting a couple of questions. How do we clean such data before making decision on the relevant data? Stephen asked that question in the chat window. Well, Stephen, there are various methods to clean the data. It depends what kind of cleaning are we talking about. So let's say if there is a missing data, then we can drop the missing data. We can impute the missing data. We can make replacements to the wrong data if the data punched in is incorrectly punched in. So there are ways that we can use to clean the data to make it to get it ready for our machine learning model, and that is all part of the EDA process, the exploratory data analysis process. We're not just visualizing the data in that part. We're also cleaning the data and getting it ready for our machine learning model. And we'll talk about them more in this program if you decide to sign up. We do have dedicated 2 or 3 weeks for that part, for cleaning the data. For example, if the data is skewed, let's say, something like this, if the data is skewed, then we need to know that these outliers, are they going to impact our machine model, and how do we deal with them? Okay. So there are ways to treat the outliers. We can drop them, we can bring them, we can bring them to that normal side, or we can treat them as a separate data. We can just treat them as anomaly as well. Yes, in this program, we will cover these techniques. There are, I think, 3 or 4 weeks are dedicated for the first 3 or 4 weeks are dedicated towards this data cleaning, imputation, treating the outliers, statistical analysis, mean, median, mode, 5-point summary, how to see if the data is needs to be cleaned, if there's error in the data, if there are data type errors. So we'll learn all this in the first 3 to 4 weeks of this program. Okay. Jermaine is asking, since everyone's brain has different thought patterns, how do you narrow down the information that is mostly commonly used in the society? That's an excellent question. So this is where the subject matter expertise will come into play. So even though the basic model, let's say, even though the basic model is the same, for example, we talked about C and tree or linear regression, but the application of that linear regression in a different segment is totally different. So this is where the subject matter expertise will come into play, and you will modify those models. You will modify the information, or well, not modify the information, but you will play with the information in a way that suits your problem, that suits your business. So even though the fraud detection algorithms under the hood are the same, decision tree, the neural networks are both financial world and the healthcare world, but because the applications are totally different, so the subject matter expertise are involved, and we modify those models according to our, and that's exactly what it is. So yes, everyone has different brain patterns, different thought patterns, sorry, but the subject matter expertise will help you to answer your business, and business need will also drive you into in one particular direction. So that's how we process the information. That's how we do things. That we always try to relate things to the business need. So in every data science project, in any data analytics project, the first thing that you will do is to define the business need. Why do you want to do this? What is the need? How can we solve it? Okay. So once you have come up with the business need, then you will decide the metric. How are you going to measure your success for that business need? Okay. And now that objective and the metric that you have defined will drive you in the right direction. Okay. That which information path you have to go down. Okay. So I hope that answers your questions. Okay. So going back to what we have, so with the credit card example that I was giving, with shrinking physical, because of COVID, you can see the banks, brick and mortar locations are now reducing. Banks are closing down their branches. It's going more and more digital, more and more online. Even the healthcare, when COVID hit, most of our members, we call our insurance customers members, they went from walking into a clinic to a telehealth. Right? So even the physical location of the clinics are now going out of fashion. So telehealth is more coming in. So there, and the fraudsters are always looking for a way to exploit the system, because fraud is very, very dynamic. You cannot have one kind of a model. You cannot have one kind of a thought process and that thought process be valid forever. Because fraud is always evolving. It's always dynamic. Things will keep changing, and you have to stay ahead of the curve. So because of the increasing volume of the digital payments and the speed of processing of transactions, it has become increasingly important to be cautious and aware of the threat posed by cyber criminals. So the primary tactic used by the cyber criminal is to defraud banks and their customer, including account takeover, new account fraud, impersonation, purchase scam, and phishing. According to a survey done by KPMG, over half of the respondents recover less than 25% of the fraud. And I'll give you another statistic. 10% of all the financial transactions happening in the world, including healthcare financial transactions, are fraudulent. Okay, and so you can imagine the scale. Okay, so if you the financial transaction, the banking sector take place at a billion or trillion level every day. 10% of that is fraudulent, and that's a big number, and that number is growing every day because fraudsters are always looking to find new loopholes in the system and exploit them. So with the amount of financial losses faced by the banks and the financial institution due to fraud transaction, the industry has started to switch from a reactive investigation approach to a proactive predictive approach, and machine learning data science has a key role to play here. And this is what our company used to do as well. In the past, when there was we didn't have a machine learning capability. So what they would do, they would analyze the data manually. A fraud investigator would just randomly, they would rely basically on tips from both the clients, from colleagues, from friends. They would rely mostly on tips. So if they get a tip, they will go look at the data of that particular healthcare provider and see if there's a fraud going on. And then they will go after the money. And so it was after the fact. So once the fraud has already taken place, the money is already going out of the door, just after the fact going after that money. And as you are all aware, going after the money after the fact is really difficult, and recovering it is really challenging. And then when we implemented the in proactive approach, machine learning, we started doing that. We built the system 3.5 years ago, I should say. And now we are looking at it proactively. So as soon as the claim comes into the door, we are checking it right there so that the money doesn't go out of the door and we don't have to go run after the money. So we are being proactive and we're stopping the money from going out of the door. So because if the money goes out, then after the fact, recovering it after the fact requires more resources. You have to have a full-time fraud investigator looking at it. In some cases, you have to involve the law enforcement, and that adds to the cost as well. So being proactive will help in cutting down the cost as well. Today, we'll just give an overview of the decision tree model that we usually, it's one of the models that we use for fraud detection. And it is one of the most popular techniques and very effective machine learning algorithm, which works well with both the categorical variable and continuous variable. Without going too much into the detail what those two variables are, continuous variable is a number, so speed of a car is continuous. Price of gas is continuous. Anything that has numbers, a number that could be a fraction that has a decimal point is a continuous variable. Categorical variable, on the other hand, is something that they could be numbers, but something that cannot be. For example, color yellow and color blue; those are the two. Yellow and blue would be your categorical variable. Similarly, the type of a car is your categorical variable. Gender is a categorical variable, male and female. So decision trees tend to work well with both regression type of modeling or with classification type of modeling. So when your target variable or what you are trying to predict is a categorical variable, it's called a classification. And when you're trying to predict a continuous variable, for example, or what will be the price of gas next month or next week or in the next 1 hour, that will be a regression kind of a problem. So decision trees tend to work very well with both classification or regression kind of a problem. And another advantage of decision tree is that it is a graphical representation. So you can visually see how the decision making is happening. How is the data being split? So what the decision tree actually does is that it tries to break the data set down into pure buckets. So it tries to remove the impurity, if you will, as much as possible. And then it will break it down. It will break the data set down such that the impurity is the lowest in that particular part of that data. Okay, so it has following components such as the root node. That's where you start from. That is a starting point of a tree where the data starts dividing. That's the topmost node. Then we have the decision node, which represents a test on an attribute. That's where you make a split. Branch represents the outcome of the test, and leaf node represents the prediction. So that leaf node is usually the last node in that branch. Okay, the path from root to leaf represents the decision-making rules of the decision tree, and decision tree makes its rule based on measures such as Gini, impurity, and entropy. I'm not going to go into too much of the detail here. But entropy is more familiar. I think you guys, everybody has heard the word entropy at some point in high school or college. It has exactly the same definition. Entropy is a measure of impurity. Even in chemistry or even in physics, entropy is a measure of impurity. Right. So if you have two gases mixed in a container, entropy is high. Okay. So it's the disorderedness. Measure of disorderedness is in physics, the definition is that, and it's exactly the same. If the data is disordered, and here disorder is impurity. Impurity means mix, mix of different kinds of data. Okay, and when I say different kinds, it does not necessarily mean one is financial transaction and the other one is color of a car. No, it's the different nature, different pattern inside that data. That's what is a mix. That is what is impurity. And what it tries to do, based on the entropy value, which goes from 0 to 1, it tries to separate the data into pure buckets. So if the entropy is 0, data is pure. If entropy is 1, data is impure. Well, okay, so Shoaib is asking a question that what is the relationship between scikit-learn and decision tree algorithm? Scikit-learn is a library of Python, and decision tree algorithm is one of the tools inside that library. Okay, so you can think of scikit-learn as your toolkit. So that toolkit has the flathead screwdriver. That toolkit has the Phillips head screwdriver. It has the drill machine. It has other fancy tools in it. So scikit-learn is that toolbox, okay? And then decision tree is one of the tools in it. So you can think of decision tree as your Phillips head screwdriver, okay? Or a drill machine, okay? So scikit-learn is a library that encompasses all these algorithms: decision tree, linear regression, logistic regression, scalar vector machines, random forest, AdaBoost, gradient boost, neural network, you name it. They are all part of scikit-learn. And that's one of the Python libraries. So if we are a bank and we want to see if we should give out a loan to this person or not, so this is that example. The first root node is that we look at the income. Okay, so now is the income less than $40,000? That is the first decision rule. Okay, that's our first filter or first criteria of that application. So if you have been to that any loan process, even the home mortgage, you see that they ask that, what's your income? What are the loans that you have to pay? So those questions are decision rules, actually. Okay, and decision tree model is actually using those same your answers to those questions as one of the decision rules. Okay, so is the income less than $40,000? That's a decision rule. Okay. If yes, okay, or no. So the very first question you're asking is the root node. So the first question that they ask is your root question, decision rule for the root node. Okay. If yes, then they go into the second set of questions. If no, then you go into another set of questions, right? So if it is yes, then what is your age? Okay. Are you less than 20? You're less than 25 years old? Because all these questions are not just made out of are pulled out of the sky. These questions are based on historical data. So it is understandable if you're younger than 25, you're probably still in college, you're not earning a lot of money, right? And you might need a student loan. But if you are over 25, if you're earning more than 40K, then then the age doesn't matter. Okay? Then we go back to another question, that is the credit score. Okay, so if you're after doing the yes question, what the next question is if your age is less than 25. If yes, how have you made payments on time in the past or on time in the past? Okay, so if you have paid, if you have made payments on time or not, and if you have answered no, then what is your credit score? Is it less than 650? Okay, if yes, then have you made payments in the past on time or not on time? Okay, and those last nodes in that decision tree are your leaf node. That's the prediction. That's the final outcome of the whole of this process. Okay, and then you will see that other questions will come in. They're not shown here, but let's say this is our last node. Hypothetically speaking, let's say these are our last node. Okay, if a person is less than 25, no, they will not pay on time and they will default because they're still in college, they don't have a job, they're full-time student. Okay? And if they are not less than 25, then probably they are in their professional life, and there's a probability that they will pay off the loan on time. Okay? And the same goes here. If the credit score is less than 650, no, they will not pay on time. And if the credit score is greater than 650, yes, there's a chance they will pay on time. So you will basically deny the loan for these people, and you will approve the loan for these people. Okay? So with every decision, you're filtering the data and you're putting the data into pure bucket as much as possible. Now, in another bank example, bank transaction fraud detection, suppose that you're part of the data science team of a bank and you have been provided the customer transaction data across over the past year. The task at hand is to analyze the data, build an ML model to predict whether a given transaction is fraudulent or not, and identify the important attributes that characterize a fraudulent transaction. So we will go through this whole process, the solution approach. As I said, the first thing now that we are defining the problem first. Remember the question that came up earlier, how do we make sure we are in the right direction? So first we set up the problem statement, the objective, okay? So we want to build an ML model to predict whether a given transaction is fraudulent or not. That's the important objective, okay, for this problem. And the bank is facing the fraud problem. That's the business need. Objective is to build a machine learning model that can detect a fraud and identify the important attributes that characterize a fraudulent transaction. So first, we'll do EDA. We'll conduct an exploratory analysis to get a better understanding of the data. Do we need to, is there impurity in the data? Is the data wrong? Is the data missing? Has the data been engineered with? Okay, has someone played with it? Or did someone tamper with it? Okay. Are there any security concerns? Right? Is someone stealing the data? That's all comes down to the exploratory part. Then if there is the need to process the data, okay, then we'll do some pre-processing. I can't go into the detail of all of them because we are running out of time. So we'll pre-process the raw data to get it ready for analysis and for our machine learning model. Then we build the model and evaluate it on the metric of choice, whichever metric we chose. The metric means criteria of success, measuring the criteria of success against the reference. So whatever metric we choose, we will measure our performance of our model with reference to that. Is it accuracy? Is it recall? I know these are jargon words. So, for example, for fraud transaction, your metric would be number of transaction that you stopped, okay, or the amount of money you stopped in a fraudulent transaction, or the amount of money you recover. So if you're talking in terms of real world language, then that's what it is. Then you can translate the machine learning metrics, the jargon metrics into those. Like how much money did you stop from going out of the door? How much money did you end up recovering? How many transactions you stopped? Okay, so you will evaluate your model based on the metric of choice, and then you will list down the key insights and conclusion from that analysis. That what are the transactions look like? What are the characteristics of a fraudulent transaction? How can we stay ahead of the curve? Okay? And then, of course, remember the first slide. You will, based on those decision making, you will create more data. Okay. So, if we're still continuing the back example, the data we have falling data which has 1 million customer transactions. It has transactions such as distance from home. It has data such as distance from home, ratio to median purchase price, repeat retailer, use chip, use PIN number, online order, and if it is fraudulent or not. So this is just a sub-sample of the data. And fraud is our target variable. 1 would indicate there is fraud, 0 would indicate not fraud. Okay, so we are looking at basically how far you are from home and you're making the transaction. Are you driving 500 miles every day to make a certain transaction? Okay, 500 miles going and 500 coming back, that's 1,000 miles a day, and which is practically impossible. Okay, because you have jobs. And if the card is used with like physical, I'm not talking about the online transaction. The online transaction has different fingerprint. It has different characteristics. Of course, the online transaction can take place if you are, let's say, you in US or Canada, and then transaction can take place in China or India. That is possible, but it has a different fingerprint than a physical use of the card. Ratio to median purchase, repeat retailer. If you have used that, if you've done transaction with that retailer before in the past, if you use the chip or not, did you tap the card? Did you swipe the card? Did you insert the card and put the PIN in? And if you use a PIN number or not, if it's an online order or not. So we have these different characteristics different variables, different data set that we can use to actually see the pattern of the fraudulent transaction. So the one problem with the fraud detection is that the data set is always imbalanced, right? As I said, 10% of financial transactions are fraudulent, but 90% are legitimate. Okay. So how do we find this needle in the haystack? Okay, so Abraham, how does a data scientist determine the limit between the data engineering and data manipulation? Well, it all depends. That's a very good question. There's no one right answer to that question. It all depends. If you're in a startup company, if you're working in a startup company, you are basically doing all the roles. You are the data engineer. You are the data scientist. But if you are in a big company, those roles are defined. Your team leader will actually draw the lines between the data engineering and the data scientist part. So it all depends. There is no wrong or right answer to this question. It's all situational. Okay. And so in some cases, you will have the hat of data engineering and data scientist at the same time. In some cases, you will only be wearing the hat of data science, where your main purpose is to you do the EDA, clean the data, and then build the model according to the need. Data engineer at that point will basically be the one that will maintain the data, that will provide you with the data, and they will be working with the database administrator to get you that data and the features that you need, the variable that you need for that problem solving. Okay, but it's all situational. So in most cases, team leader will basically will determine where to limit. To your meaning, how to deal with such unbalanced data? Well, there are techniques that we use. We can undersample, oversample. There are techniques to deal with the unbalanced data. Decision trees, on the other hand, there are very robust, they don't care if the data is imbalanced or not. So that's why decision trees is one of the most popular techniques out there. But if we're not using decision tree, if we're using something else, there are ways to deal. Okay, I can't go into the detail of all this in today's session. Okay, so 90% of the transaction data are proper, the rest are fraudulent. Approximately 1/3 of the transactions are online orders. So as you can see, this is the part of the visualization. This is the part of the EDA where we are charting the data to see what are the characteristics of this data. So we can see 90% are legitimate, 10% are fraudulent, and out of all of the 100%, 70% are in person, in physical, whereas the 30%, 35% are online. Is the left curve fraudulent or just another or amber rectangular shape? Okay, so this is legitimate transaction, and this is fraudulent. Okay, so amber would be your fraudulent. 1.0 means fraudulent. 0.0 means legitimate, not fraud, because your scale is fraud. You're going from 0 to 1. Okay, there are two classes: fraud or not fraud. 0 would be your not fraud. 1 would be your fraud. All right. And similarly here, online order. So here 0 would be okay. The thing is, these are switched. The 0 should be online. The amber is online here, and then the not online is blue. Okay. All right. So when we do the exploratory data analysis, as I said, we also look at the other things such as the distribution. As you can see here, if we are looking at the ratio to median purchase price data, this is a box plot. So you can see this data is very heavily skewed. So that means there are transactions that are extremely large, okay? And that is an indicator. That is one of the indicators of fraud, because the transactions are extremely large. And if you look at these transactions with respect to the fraud variable, you see that in a box plot we have this is the first quartile, that is the 25th quartile. This is the third quartile. This line is median. Okay, this is Q3, and then we have Q4. Okay, so you can see when the transaction is fraudulent, 1.0, the median purchase price is higher. Median transaction is higher. Okay, which is understandable if the transaction is large, because the fraudster doesn't have enough time and patience to do the transaction and do the fraud 1 cent at a time. Well, they can, but they usually don't have the patience and the time, because they are on the run. And at any point, company can plug the hole. Okay, so they usually do this in bigger chunks. So you can see the fraudulent transactions have a higher median purchase. Similarly, if we look at distance from home, for the fraudulent transaction, the median distance from home is slightly higher. It doesn't make much of a difference. Oh no, I should take that back. For example, this 10,000 kilometers or miles, whatever the scale is, no one can do that. Okay, so that's definitely an online transaction. So the distance from home is not a direct indicator of the fraud. Okay, because it could, but then we also have other variables that back that information up. That okay, this is an online transaction and not done physically. Remember, in the old days, your bank would ask you to do a travel notification. That if you're going out of the country, you need to tell them so that they don't block your transaction. That was the exact same reason, because at that point we didn't have that many variables, right? That could tell us that you are traveling. Now we have those. When you purchase an airline ticket, we know you bought an airline ticket and you would be traveling, okay? And you would be traveling to a certain country. So we know that. But that's why we don't need that information anymore, that you are traveling. We already know. Okay. So so these are the reasons you needed to give that notification, because distance is not a direct indicator unless you are doing it very often, unless you're going back and forth every day, right? 10,000 miles every day, then becomes an indicator. Okay? So in the data pre-processing, in this, we'll split the data 70-30. That's a very common split ratio. And then we'll feed that data to our model, and then we'll use the evaluation metric to see if the model is doing very well or not. So this is how the model will kind of look like. Here we have the decision on each node. This is our root node, which says if, and then the next, if this is yes, and then this is no, then we'll go through this node, and then we'll go through this node. The total recall of the training is 100%, and recall of the test is 93.3. Recall is one of the metrics that we use. You can call it as a conversion rate if you want to talk about it in terms of business language. I'm not going to go into the detail of what recall is, but it is one of the metrics that we use to detect the performance of the model. Okay, so and now these are one of the most important features the model has come up with to which can give us an indicator of the fraud. So ratio to median purchase price, that is one of the, you can see that it has the highest importance. So that means if the purchase price is high, that is the biggest indicator of the transaction is fraudulent, at least for this particular data. And then distance from home is the second biggest indicator, then online order, then used chip, and then used PIN number. And you know, if someone used your card and used PIN, that means there's a higher chance that you shared the PIN with them and you handed them the card too as well, unless your card was compromised at the gas station or something where you put the card in, they took the number, you punched in the PIN number, they took that number, and then they generated a new card based on the number and PIN. That is possible, but those are very low indicators of fraud. The purchase price is the most important factor. That's one of them, and then followed by the distance from home. If the transaction is happening every other day at large distances and in person, those are big red flags for you. Insights: the decision tree model can correctly identify 93.3% of the fraudulent transaction. And as I said, the ratio of the median of the price of all purchases is the biggest indicator, followed by the distance. Followed by the other metrics such as if it's an online order, if the chip was used, if the PIN was used, and if it is the repeat retailer.